If you ever looked under the hood of a commercial VPN, you would know something interesting. Most VPN providers don't actually build their own protocol. They rely on technologies like WireGuard, OpenVPN, or IPv2, powerful protocols originally engineered for secure networking infrastructure. And that makes sense. VPN technology didn't start as a consumer product. It was built for enterprise environments for connecting offices, securing corporate networks, and enabling remote access. But its core architecture was not designed for millions of individual users sharing infrastructure at a global scale. That's where we saw an opportunity. What would a VPN protocol look like if it were built for the users from the very beginning? That's exactly what Dausos is. How traditional VPN architecture works. Let's start with the baseline. Most commercial VPN implementations rely on a virtual tunnel interface model. In simple terms, all user traffic is routed through a virtual tunnel interface. Within that shared interface, encrypted traffic for multiple users is handled together before being routed to its destination. This model works, and it works well. But at the consumer scale, it introduces some trade-offs. Shared tunnel interfaces, packet scheduling overhead, cross-traffic processing, resource contention, and encryption layers optimized for compatibility rather than speed. While protocols like WireGuard are lightweight, modern, and highly efficient, they were designed as general-purpose secure networking tools. As I've already mentioned, they weren't originally built to meet the specific architectural demands of large-scale consumer VPN services. That distinction matters because designing a secure transport protocol is one challenge. Designing a protocol specifically for consumer VPN scale is another. What we changed: dedicated per-user tunnels. Our own Dausos protocol changes the architecture. Instead of consolidating user traffic through a shared tunnel interface, each user is provided with a dedicated private data tunnel. That means your encrypted traffic path is logically isolated. Your packets are not processed alongside other users' traffic inside the same tunnel structure. Your connection is optimized for your device, your network conditions, and the way traffic is handled on the server side. This reduces the chance of cross-traffic exposure, the potential for interference between users, resource contention that can affect performance, and shared handling within the routing structure. This is what allows both stronger privacy protections and measurable performance improvements, up to 30% faster compared to Surfshark's existing VPN protocols. Fully post-quantum secure. Dausos applies quantum secure encryption principles by default. As computational capabilities evolve, encryption must evolve with them. By integrating quantum-resistant cryptographic foundations into the protocol design and using modern encryption like Aegis 256x2, we're building resilience not just for current threats, but also for what comes next. ML-DSA Certificate Authority. We introduced new security layers, some not previously seen in VPN protocols. This includes a self-signed root certificate authority system using ML-DSA, a post-quantum signature scheme for verifying communication. In simple terms, it helps your device confirm that every connection is authentic, built to protect against both current threats and what comes next. Post-quantum hybrid key exchange. Dausos also uses a hybrid post-quantum secure key exchange, ML-KEM by X25519. It combines a trusted modern standard with a new NIST-approved post-quantum algorithm to establish secure connections. This hybrid approach protects your data against today's threats, while preparing for the risks introduced by future quantum computing. Adaptive Performance Engine. Performance isn't only about encryption speed. The Dausos protocol dynamically adapts to network conditions and device capabilities. Traffic handling adjusts in real time based on connection stability, available bandwidth, and device performance. This allows higher throughput on high bandwidth networks while maintaining stability when conditions are less predictable. Independent validation. When introducing a new protocol architecture, validation isn't optional, which is why independent verification matters. Dausos protocol has passed an external security audit by Cure 53. Security claims are easy to make. They're harder to validate. We did both. Current protocols are powerful, built for general-purpose secure networking, but only later adapted for consumer VPN use. The Dausos protocol was built differently, built from scratch, built for scale, built for isolation, built for performance. Dedicated per-user tunnels, modern Aegis 256x2 encryption, quantum-secure principles, dynamic adaptation, independently audited. And this is just the beginning.